Okay, thanks for tuning in. My name is Arnold Rangakramya, and in today's session we get to answer this question. The question says that a tennis ball is served horizontally from a height 2.4 meters and 12 meters from a net which is 0.9 meters high. If the ball clears the net by at least 0.2 meters, what is the minimum initial speed and where will it land? Let's summarize this question in a diagram. So we're going to draw a diagram here to summarize this question. So this is the tennis ball. It has been served horizontally from a height 2.4 meters. So this is the height we're talking about right there. It is 2.4 meters. That's where the tennis ball has been served from that height. And the question continues to say it has been served horizontally from a height 2.4 meters and 12 meters from a net. So it is 12 meters from a certain net. The net is right here, and from a net which is 0.9 meters high. So this net is 0.9 meters high. If the ball clears the net by at least 0.2 meters, so meaning that if, as this ball is being served, if it just clears the net by 0.2 meters, that means that if it goes above this net by just 0.2 meters, if it clears the net by just 0.2 meters, what is the minimum initial speed? So this speed here, the value of u here, is not known and we need to find it. So what is the minimum initial speed? Then to where will it land? We shall come to Roman 2 later. Let's start with Roman 1. What is its initial speed when it just clears the top of this net? So let's get started with that. Again, this is not a perfect trajectory. In other words, it's not the kind of trajectory where we are going to apply the equations that we derived. Like I keep saying, the equations we derived are normally apply to a trajectory that is perfect like that. From here, this is where you can apply the equations we derived, where you can find the equation for maximum height, where you can apply the equation for range, and then the equation for time of flight. That is when the trajectory looks perfect like that. But this is not perfect. And so, because it's not perfect, it means we're supposed to solve the number using equations of motion from first principles. And the one that we commonly use is this one. S is equal to ut plus a half at squared. The equation for displacement. Why? Because as this ball is running, it is normally displaced along the along the y-axis and along the x-axis. It's normally displaced along those axes, and from there we are able to come up with some equations that will help us to, find a few unknowns here and there. One more thing before we go into the number is the thing I also like to emphasize. When something has been projected from here and it goes up and then it comes back down like that, this is our zero level. So when the particle goes up, that is positive displacement. If it comes and goes beyond this zero level and starts moving downwards, that is negative displacement. And the negative displacement here, we are talking about displacement in the y direction. Take note of that. So when you look at something like this, a ball is projected from here and then it falls like this. This is like saying the ball was up here and then it was kicked and it went here. But because its point of projection is here, this means that now the zero level has shifted to up there. It's the point of projection that is going to dictate where the point of projection is where that is where we are going to determine the zero level from. So this is our zero level, and so if it is moving down, it means it is moving below the point of projection, and so this would be negative displacement and upwards would be positive displacement. That's just how it is. So let's get into this now. So meaning from here, we know that as this one is being projected from this point to come down here, because this is the point of projection, it means that this right here is our zero level. Because this is the point of projection, this is where the thing was. And so if any displacement is negative displacement in the y direction. Yeah. So let's get started. Like I said, when we are doing these kinds of numbers from first principles, it's going to be, we're going to play around with S is equal to ut plus a half at squared. Now, we're going to look at displacement, this ball. By how much has it been displaced in the x direction, and by how much has it been displaced in the y direction. If you see that it is here in the x direction, it has been, we are going to look at, it has been displaced. We have some information here. In the x direction, it has been displaced 12 meters right there. By the time it reaches this point, as the ball moves to here to there, it has been displaced 12 meters in the x direction, and then it has been displaced by that distance in the y direction. What's that distance? Remember, we are counting from the zero level. This is the value of x, this is the value of y. In the value of x, it has been displaced 12 meters in the x direction. In the y direction, it has been displaced, what is that? So we know that this is 24 meters. So 2.4 meters. So 2.4 minus 1.1, we get 1.3. I hope we are not confused. Let me emphasize this again. In the x direction, by the time the ball is here, in the x direction, it has been displaced. In other words, the displacement in the x direction here is the 12 meters from here to there. Then in the y direction, to reach here, this is 2.4 meters. This is 0.9 plus 0.2, which is 1.1. So 2.4 minus 1.1 gives us 1.3. So in other words, this is our displacement in the y direction when the ball has reached that point. So since we have our x and y, it's like displacements, then we can use this expression to find out what they want. In this case, they want us to find the value of u. So let's get started with the working. So let's begin with displacement in the y direction. Displacement in the y direction is given by ut plus a half gt squared. That's going to be given by, what is the value of u? Now, the initial velocity in the, in the y direction, remember the question says that this tennis ball has been served horizontally. If it has been served horizontally, it would mean that there is no component of this velocity in the y direction. Maybe this is another way to put it. Remember, previously we've been dealing with where the velocity goes up at a certain angle theta. Yeah, this is velocity u, yes? And so meaning that if we are looking at velocity in the y direction, we would resolve this by saying it is u sine of theta. That would be velocity in the y direction. Then in the x direction, we would resolve this velocity along the x direction and we would say it is u cosine of theta. Yeah, but now in this case, this velocity is acting within the x direction. That means that the value of theta is 0. That's what the question says, that the tennis ball has been served horizontally. So if it is acting within the x direction, it means that the value of theta here is 0. So if it is 0, let's put, so meaning that in the sense of y, what is sine 0? If we say u sine of 0, the sine of 0 is 0. So it means that it's going to become u times 0. U times 0 is going to give us 0. So that means that in the y direction here, this u sine of 0 means that there is no component of the velocity in the y direction because this thing is all in the x direction. So this term is going to die because of this explanation. And of course, later on when we come to the x thing, What is u? Cosine of 0. Cosine of 0 is 1. So u times 1 is u. So the component of velocity in the x direction will be u, but we shall come to this. So this here, as we are substituting this in here, it's going to become, this is 0. Because there is no component of the velocity in the y direction. So 0, of course, this is plus a half. Gravity is in the negative direction, minus g. T squared. This is equal to the displacement in the y direction. We are looking at it at this point. That is at that point, the displacement is negative 1.3 because it is in the negative direction. So this is negative 1.3, like that. So this becomes negative 1.3 is going to be equal to negative, negative g, which is 9.81, negative 9.81 over 2, and that is t squared. Multiply both sides by 2, you end up with negative, of course these negatives will go, we end up with 2.6, divide that by 9.81, giving us t squared. And our value of t here, when we find the square root on both sides, here, we end up with, that is 0.5148, this is in seconds. So that is what we ended up when we did displacement in the y direction. So in other words, this value of t, that's the time it takes for this ball to move from there up to that point. So now that we have done displacement in the y direction, what about the displacement in the x direction? Let's do it right there. So the displacement in the x direction, that is x in the x direction, still it's going to be ut plus a half gt squared. Displacement in the x direction is 12 meters, so we shall come and say 12 meters is going to be equal to u. Now remember, this is what I was explaining earlier. This is what I was explaining earlier, that u here is the value of theta is 0, u cosine of 0 is 1, cosine of 0 is 1, so u times 1 is u. So, and also the thing has been served horizontally, so the value of u, or the velocity, is in the x direction, so it's definitely u times time. Now the time we got, this time applies because the same time that it took for this ball to come here to there to have this vertical displacement is the same time that it took to make that horizontal displacement. So it is u times the value of t, which is 0.5148, yeah, this times that, then plus a half times g times t. Now this is in the x direction. In the horizontal component, we do not have gravity. The value of gravity is 0 in the horizontal component. So because the value of gravity is 0, it means that this whole term is going to die. So it's simply, in the x direction, it is just that, plus 0. In our previous sessions, when I was dealing with displacement in the x direction, I would simply say distance is going to be equal to speed times time. Now I think you're seeing where the speed times time thing is coming from. It is coming from the fact that this other portion, the gravity in the x direction, is 0. The gravity is only acting in the y direction. That's why here it is considered, this term is considered. But in the x direction, it is 0. That's why we simply remain at the, we call it distance is equal to speed times time. But to be more accurate, it is displacement is going to be equal to velocity times time. I think you see the difference here in scalar and vector quantities. When I said distance is equal to speed times time, distance is a scalar quantity, speed is a scalar quantity. And then when we term it in displacement is equal to velocity times time, velocity is a vector quantity, displacement is a vector quantity, velocity is a vector quantity. Yeah, you get what I mean. So that is how we come up to just this dice. So this is going to be, when we make u the subject of the formula, it's going to become 12. Divide that by this. And the answer we get, so looking at that, we have answered the first question. The first question says, what will be the minimum initial speed? That is the initial speed. The minimum initial speed when the net just clears. If the ball clears the net by at least 0.2 meters. So when the ball clears the net by just, 0.2 meters, that is the initial speed, which is 23.309. So we've done Roman 1. This is Roman 1 of the question. So now let's get to Roman 2. So Roman 2, where will it land? So by Roman 2, when they ask us where it will land, they're asking us to find this distance here. Because once it clears this by 0.2, it is eventually going to land here. So where will it land? We want this distance. That's the displacement in the x direction. That's what we want. By the time here, where will it land? So here, by the time it's landing here, let's see. By the time it lands here, we will have gotten, this is like our origin, right? The point of projection is our origin. So if the point of projection is our origin, what will it be? Its displacement in the x direction will be this. It's what we want. What is its displacement here in the x? Let me call it sx prime. Then in the y direction, what is its displacement in the y direction? In the y direction, by the time it lands on the ground, remember the ground, it is 2.4 meters above. So this is 2.4 meters. So at the point where it lands, we know that our y displacement is negative 2.4. Actually, this is negative 2.4. Negative 2.4, and our x is positive something. We need to find the displacement in the x direction, and that's how we shall be able to know its displacement at the point where it lands. So let's get to it. Again, we are going to use the other equations of motion. Still from this, when it is at the point where it lands, its displacement in the y direction is going to be ut plus a half gt squared. So again, its displacement in the y direction will be negative 2.4. So this is negative 2.4 is going to be equal to, of course, I already explained that this is 0. The thing was served horizontally, so there is no component in the y direction as far as initial velocity is concerned. So it's going to be 0. This g being a negative will be minus a half times 9.8 times t squared. And so making this is going to become negative 2.4 is going to be negative 9.8 over 2 times t squared, and definitely this is going to become, making t squared the subject of the formula, multiplying 2 on both sides is going to give us 4.8. When you find the square root on both sides, so from that we're able, from our formula for vertical displacement, we're able to find that by the time it lands on the ground, the time spent will be this 0.6995. So now we can go ahead and find the horizontal displacement, which we are being required to find. So displacement in the x direction, sx, is going to be definitely the same, ut plus a half at squared, and this is going to be equal to, the u is what we got earlier, 23.309. Multiply that by the time taken to reach there, which is what we got here, 0.6995. Remember, plus this one is 0 in the x direction. I explained why. So that is going to give us 16. So after getting the value of 16 right there, then we can go ahead and say we've answered this question, where will it land? So we shall simply come here and say that it will land